I'm Jason Lopatecki. I'm with Arize AI. We are the leading evaluation and observability company out there. We probably have more and see more LLMs in production than most other companies. So a lot of, I think, talk today feels a little high level to me. This is going to be pretty technical. This whole talk is on agents, agent evaluation. So how many of you feel like this is kind of the year of agents? I definitely do myself. You have companies like Laying Chain, launching Laying Graph, been around a while, but it's probably one of the lower level frameworks for agent building. You've got Llama Index with workflows, event-based. We'll talk a bit about that. Crew AI is a little bit more high level in terms of agents, and then probably the missing one from this is AutoGen. So you've got a whole set of tooling there to build agents. And it's powered by a lot of what you see on the right here, which is tool calling. Tool calling is kind of the core, one of the core pieces to building, but we're going to get into a lot more of this. The real question is, like, how do you make this stuff work? And one, we have probably more customers live with either trying to deploy agents. We have an agent within our own platform, one of the, I think, the better assistants out there to help you debug AI. And so we have a lot of experience in this. Well, what do we see? Well, I think you're going to see, if you talk about agents, you're going to see a lot of complicated graphs. You're going to see a lot of complex stuff out there. Really, what we see in all of our customers, they start with something really simple like this. This is a two-stage router and skill architecture. So what does that mean? You've got an LLM at the front end determining a user's intent, routing it to a skill that's taken care of by another LLM call. So, like, forget all the noise you hear out. Like, this is what I see a lot of people doing. So this is the simplest thing I would try to understand first. There's a router and there's a skill. And then how do you make this actually do something? Well, typically you send it back to the router. So either there's a user stage in between this, or you're kind of doing different steps of an agent without a user interaction. But this is probably most of what you see out there architecture-wise. Forget all the complexity people say, forget all the stuff out there. This is probably it. Now, what I'm going to get into is a little bit more of like, okay, where does this go? How do you debug this? How do you evaluate this from an LLM evals perspective? So, well, there's another level of complexity, I would say, that we also see out there, which is there's not just a router and a skill, but there's a stacking of those together. There's state, typically where information's passed from one output action to another. But this is probably the core of most agent architectures out there. It's a decision of what to go do. It's an LLM debugging, and then it's kind of basically state below this. Now, this so there's frameworks that try to make this easier. A lot of what I would see out there is probably agents in code. Code is kind of probably the first thing you should start with, maybe not a framework. And kind of what this looks like, is basically the router is doing tool calls. It's an LLM that's determining the intent of what the user is trying to do, calling a tool. The tool itself might be a general purpose function, or it might be another LLM pass on some set of data. There's some state below that that's feeding in to both the router that's determining what to go call, and the tool itself, the skill itself, but below that tool call. So this is the core building block that if you're building an agent, you should start with. But you can realize that getting the tool call right, am I calling the right thing? Am I extracting the right data? Am I doing the right action below this? And this particular example is kind of taken from a chat to purchase, where I'm interacting with an e-commerce assistant and just potentially purchasing a product or looking up a product, which we see as a common example out there in the e-commerce world. Now, the difficulties of evaluating this agent. So what you see here is what a lot of teams have, which is a couple lines of code. Seems pretty simple, but an immense amount goes on under the surface. What you have on the right here is actually our product. We have an open source product called Phoenix, one of the more popular open source observability and evaluation software out there. Check it out. Pip install Arize Phoenix. But underneath this like 3 lines of code, you've got probably 100 distributed system calls. Like a couple lines of code, incredible number of calls to different distributed systems. It might be retrieval that you're doing, it might be API calls you're doing, it might be 20 different LLM calls you're doing underneath the surface of these. So the first thing to get a handle of is what in the world's going on in those 3 lines of code. So that's where Phoenix steps in. I think we trace 20 different platforms right now, from AutoGen to the crew to LangGraph, you name it, 1 line of code, you can see what's going on under the surface. So first off, what's going on? What are these calls actually doing? The next phase is like, how do you run evaluations on top of those? What are like, is it LM evals? Is it code evals? And we'll talk a little bit about how to evaluate the effectiveness of what you're doing below the surface. So the first thing you need to do, and I think most teams need to do, is trace their agent to understand what it's doing. What might I trace and what might I need to understand? Well, typically, there's a router that's kind of doing a like intent lookup to then determine what skill or action to take. And the question is, like, did they get that routing right? Did I call the right skill? So there's kind of one thing here is, am I routing to the right skill? The second piece is the skill doing the right thing? So those are the 2 different things you might want to evaluate. In this case, I might have a customer asking a question. He might be looking up something to purchase, or he might be just asking a general product question. So I'm responding in different ways depending upon what the user is asking to do, and sometimes it's and in both cases, the example here, I've got an LLM also in the skill itself. So the skill could be a function call, it can be an API call, it doesn't need to be an LLM call fed back to the router, but typically I'm doing 2 LLM calls here, a router and some type of skill. So this is kind of the simplest form of agent. Now we'll talk about more complicated ones in a bit, but like this is, I would say, 90% of what I see. It can get more complicated. So this is an example of a real production, this is what we see in some cases from a production perspective. And you can see the branch, basically there's a router at the front. There's a branch to go decide what to do. This is a chat to purchase. I'm talking to e-commerce. I'm potentially wanting to purchase a product, but it might be doing a product lookup. I might be asking for support on something. There's a lot of things I might be doing when I'm chatting with this assistant. The branches, in the little yellow triangles mean LLM calls. You can see some of the branches don't have an LLM call. So I might just be looking up a product, returning something to the router stage. And some of these actually have 2 LLM calls underneath. So I might be doing a lot. So this is, again, in its simplest form, I would say what I see, what architectures I see, is this kind of router kind of skill architecture with a loop on it. And again, we're going to get into how do you evaluate these? How do I know they're doing the right thing? What do I care about? What do our customers care about? But this is kind of what it looks like as you're actually deploying one of these, a real architecture. And this example right here, and I say most of our customers are actually doing this in code. Like there's frameworks out there. There's a lot of frameworks. I would say that some are positive, some have strengths and weaknesses. But I would say most people I currently see are actually kind of doing this in code that they build versus the frameworks. The frameworks are pretty new. You've got to learn the abstractions. So I think there's strengths, and then I think there's actually what I see going on out there. So either one you do, we have tracing options for you in debugging. I would say if you're using a framework, you need some tracing options. Some of the lower level frameworks that are pretty new out there are going to be Lane Graph, which is, think of nodes and edges. Llama Index just launched Workflows, which is kind of event-based. Has some advantages, I think, to the way you think about things. But these, you can see some of these, there's maybe router stages in the beginning that spread you out. There's loops here to decide when you come back. So there are different ways of abstracting these kind of branch and flow that you were seeing in the earlier stages. So they're abstract. Like if I squint at some of our customers, and our own assistants architectures, I can kind of see the nodes and edges, but they're like an abstraction layer on top of what's there. And I would say lane graph is kind of like, maybe lane chain started with chains, now they got loops, so let's do a graph. So an extension of where they're going to go. Now, the hard thing is not building something that you demo on Twitter. It's that it happens every day. The hype cycle is big. Most of that stuff is just unusable in production. Not like, and the hard part is not making the Twitter demo and making a first POC. The hard thing is actually making something that you're comfortable putting into production. You're comfortable putting into in front of your customers, and it's not going to go. Say that it's not. It's not going to make up something or do something that you don't want it to do. So I would say the hard thing is not that first POC. The hard thing is actually iterating on this stuff and making it solid. And so we'll talk a little bit about what we think you need to do that to make this stuff work. Obviously, I'm going to give you a plug for what we do, observability and evaluation in the first set here. But I honestly think I don't know how anyone deploys stuff without tracing. Like this, there's just so many things going on in these systems. I think it's, we couldn't launch and run our assistant without, our own tools. So first off, it's like understanding what's going on in the surface. I would say a lot of it is also starting to build out, test sets or example sets to make sure the skills you have are working correctly, and then maybe the questions and routing are working correctly. So building out little golden data sets that you want to test it when you make a change. The biggest thing we see, the biggest problem is a prompt change just flows through the system in terms of breaks. So because you have LLMs feeding LLMs, like a small change somewhere can actually ripple through in a lot of ways you don't realize. A change to the router can break your extraction, parameter extraction, which breaks your downstream skill. So the biggest thing is how do I get tests in place so that when I make a prompt or model change or a new model comes out, I kind of have a quick view of what's broken. The other one is breaking down the individual steps. I was saying okay, there's a router stage, there's kind of a skill stage. You'll kind of get at like some teams are, the skill's really important. It's important to get right. I need some tests on this, and so this is my high priority thing. I'm going to go build tests for. Some teams, the intent and routing is most important. So I think you need to figure out based upon your use case what to go build out. And then there's the experiment and iterate, and you got to have tools in place to help you test and check your results. I'll talk a little bit about what does an eval look like at the router stage. So I don't know. I'm sure you've heard about evals a lot, and I'm not sure how many. I guess a question for all of you: how many of you have built an evaluation, or how many of you heard of evals? I mean, everyone's probably heard of evals. Okay, how many of you built an eval? Okay, not that many. Wow. So what are evaluations? Are it's just a fancy industry word for understanding performance or results of what you built. There's kind of two ways that we see out there of doing that. There's kind of there's the more fancy way, which is actually using an LLM to understand whether your LLM returned the right thing. And as crazy as it sounds, it's actually pretty useful. So I don't we use it in our system all the time. We use it for things that just are hard to do in code. like detecting, like I want something just to, I want to evaluate whether the question was answered correctly. I want to evaluate whether, the right data was returned. I want to evaluate whether I think something's a jailbreak. So these are all evals that we constantly run in our system that are LLM driven. You also have evals that are kind of code driven. So, and you write some Python, and it's like, it feels like normal, a fancy word for normal testing. But the idea is that it's either LM eval or code eval, you're checking your system. A natural one for LM evals is actually the routing stage. So did I route to the right question? It's kind of an intelligent thing. You want to know, did I get that intent routing right? And then sometimes what you're doing if you don't get it right is you're adding instructions to the router. You're saying, like, if someone says this, or someone implies this, go here. So you're building out, you're finding problems, you're building out issues. So at the router stage, you're typically determining what function to call and what parameters are extracted. Those are the two things that go down to the next stage. So you're evaluating your parameter extraction, you're evaluating your function calling intent. At the skill stage, you might, like if you really have a multi-step router versus just a single step, you might be looking at convergence or just purely like if the LLM is doing the right thing. So typically there's a stage, like if the and I would say most teams aren't doing this iterative thing right now. Like it's probably like a user, go back to the user. I think Replit just launched a one that is iterative but still has a user input. But I would say a lot of people I see right now are user stage in between. But if you are doing this iterative piece, the real question: are you converging? Am I getting decided? Like most of this stuff doesn't change after a couple of iterations, and you're just off in the weeds. So how do you have some checks that determine if the thing's actually doing what you want it to do? So there's you can do convergence evals or just an eval for your general skill, or you can do evals at the router. And what they look like what does an eval look like? Well, evals, this is a fancy word, it's typically a template. If Phoenix has a bunch, so our Arize Phoenix, which is our open source observability and evaluation, all these templates are open. You can use them yourself. But that template's kind of giving you, it's kind of like classification. It's telling you whether this thing's doing the right thing, and you're kind of using this little intelligence layer for classification. That's core of what an LLM eval is. You can, again, the most popular ones are just, did I get the question answered correctly? The other popular one is hallucinations. You'll hear hallucination evals a lot, which is, did I add a fact in that wasn't part of the data I'm generating that fact, the information from? So am I inserting facts that aren't real? So evals, agent evals, and then you'll get probably router evals, agent evals. And let's see. We're going to see if this works. Okay, so this is Phoenix. You can download it today. We also have Arize Core, which is our broader enterprise platform, but Phoenix is open source. You can run it. It's looking at function calling evals, so it's run here. It's basically a chat to purchase asking a question, and it's asking a question about a product and basically promotion, and it's coming back with product search. So you've kind of gone the wrong branch. I've asked a question about the product promotion, and I've gone down search. Well, typically you'll find a problem. You might want to add it to a data set. So a workflow typically is looking at the response of your system. You're finding spans or issues. You're saving the data sets where you're going to do some tests on. And then experiments are an area, kind of a slightly more advanced area, where you're going to test new prompts or test new data, test new models on those examples. And then we'll automatically add evals. You can kind of see there on the bottom of these examples. So once again, check out Arize Phoenix, definitely great from an open source perspective. Arize's core platform enterprise is a little bit broader, wider solution designed for enterprise deployments with some of the top teams, top AI teams out there using us, the top AI teams in the world using us. And if you're building, one, get your hands, try to build assistants or agents. If you're building anything, definitely trace and eval it, and then definitely try out Phoenix. It's there to do. Any questions?
If you have a question,
Okay.
make eye contact with Guy, who's walking around with a microphone.
Hi, thank you
Yeah.
so much for a great presentation. I have a blunt question. What do you mean by parameter extraction? It's just not the term that I've seen.
Yeah, so the question was, what do I mean by parameter extraction? Well, in function calling, which is kind of the intent routing of LLMs, there's two main things it does. It determines the function call, which is like the action it thinks you should take, and then it extracts from the data parameters that you should use in that function. And so you define as part of your tool calling definition what you think you'll need in that next stage. So you're kind of defining as part of your branching what you think you need, and it will extract it for you. Yeah.
Just have to find that agentic tool also. Would that be a possible?
Yeah, this question was different agents have different agentic tools, and does Phoenix kind of help you find that? I think Phoenix. I think you're going to have to typically you're going to kind of define what tools you think you need, and then we'll make sure you're kind of calling the right ones and or taking the right actions, and then we'll make sure it's taking the right steps to do the things. But you're defining kind of what the things should do. Yeah.
Thanks so much. Amazing talk. Ali Yusuf from Stanford University. One question is around the use of agents in mental health. I think there's a lot of conversational AI going around. One of the questions is, you thought about, there's some things where the router might break or the LLM itself might break. How do you set an ecosystem where you can monitor where the issues of breakup are happening? And if there's one of the LLMs is going wrong, how do you identify that?
Yeah, so the question is how do you set up an ecosystem, whether you're going to catch problems, and how do you figure out where the problems are? So I do think the platforms like ours, like our enterprise platform, have these online evals. So evals that run as your data is ingested and augment your data, and you can kind of that approach is typically what people are using to build in checks, and they'll check different parts of their system. So you've got think of it as AI is monitoring the AI decisions, but humans are writing those checks. And then our platform actually does have AI Copilot that helps you write the checks themselves too. So
We have time for one more question. Make eye contact with Guy. Where are you, Guy? Okay. So there's a question in the back.
How does your offering differ from something like LangFuse or Traceloop? What makes Phoenix different than those offerings?
Yeah, good. Okay, so good question. So the ecosystem right now is kind of LangFuse, Langsmith, and probably us, I would say. Phoenix is open source, so Langsmith isn't. So we have kind of an open source offering, and one of the, I would say, top solutions there. I think the developer experience and ease of deployment there is probably better than LangFuse. LangFuse is a little bit thinner but wider product. I think on the enterprise side, LangFuse probably doesn't even compete. And I would say on that side, on our main product line, in terms of breadth of solution, I think the AI integration, so Copilot, AI enablement throughout the platform, no one's even close to an assistant like what we have. I would say, I think our online evals are more built out. So helping you automate and write evals, online code evals. So I think there's a breadth of solution on the enterprise side that's broader, and then we're not just Langsmith would probably be the closest competitor, but we're not. Who wants to be tied to your framework? We're open, 20 different places we integrate, 20 different frameworks. When the next framework comes along, do you want your observability platform tied to your framework? We're open. The last point I would say is we're kind of cloud native, so your data is stored in Arrow files, Parquet files, and you can use offline systems with it versus giving all your data to a vendor. So that's probably, hopefully that gives you kind of a lay of the land of the ecosystem. Cool.